A ratio is just a way to compare two things using numbers. So here you have some snowflakes and you've got some flowers, and we can compare the number of snowflakes to the number of flowers. So there are 3 snowflakes and 2 flowers. So our ratio is 3 to 2, and we write it using 2 little dots between the numbers. So it looks like that, and we say, when we read it, we say 3 to 2. So that's one way of comparing the snowflakes to the flowers. We could also compare the flowers to the snowflakes, and it's a different ratio. It's 2 to 3. Again, we use the little colon or those 2 little dots between the 2 numbers to write our ratio. There's often more than one way to compare things, and in this case we could compare the blue items to the red items, and again we get a ratio of 3 to 2. The ratios we've looked at so far are comparing one part to another part, so they're called part to part, the snowflakes to the flowers, or the flowers to the snowflakes. But you can also compare a part to a whole, so we can compare the snowflakes, the number of snowflakes, to the total number of items in the set. So in this case, we have 3 snowflakes. We've got 5 items altogether. So we would say that the ratio is 3 to 5. Now when you are comparing part to whole, the ratio can also be written as a fraction because it's part of a whole thing, which is what a fraction is. So this ratio can be written as 3 to 5 or 3/5, which is a fraction. Now we'll take a look at this number of snowflakes to the number of flowers, and if you add them up, we're going to compare the part to part again, and we can see that there are 6 snowflakes and 4 flowers. So the ratio is 6 to 4. For every 6 snowflakes, there are 4 flowers. But this ratio can also be expressed in a different way because it's the same as saying, if you have 6 to 4, it's the same as saying 3 to 2. 6 to 4 and 3 to 2 are equivalent ratios. If you look at the pictures, you might be able to see and compare their similarity. And here's an example of another equivalent ratio. It's equivalent to 3 to 2, but in this case the ratio is actually 12 to 8. Most of the time ratios are expressed in their what we call their simplest form, the least number, the lowest numbers that they can be compared. We'll take a look at another series of equivalent ratios, and this time we're going to compare the part to the whole. So the green circles to the total number of circles, and in this case we have 4 to 5, which again, because it's part to whole, it can be expressed as a fraction or 4/5. So here's an equivalent ratio. 8 to 10. 8 green to 10 total. Again, expressed as a fraction would be 8/10. Now can you think of another equivalent ratio? Well, here's one. This would be expressed as 12 to 15. There's 15 circles altogether. 12 of them are green. 12 to 15, expressed as a fraction, 12/15. Or you can even read that as 12 to 15 if it's in fraction form. So you might be able to see the pattern here and how we're able to find equivalent ratios. Basically what this means is that for every 4 green circles there would be a total of 5 circles. And we can find the equivalents from that. And generally ratios would be expressed in their simplest form, which in this case would be 4/5. So keep in mind there are different ways to express ratios, part to part and part to whole, and you can find equivalent ratios as well.